In this lesson, we are going to be improving the rotation of the head while our enemy is pursuing us. Currently, if I go ahead and play this, and I get spotted and pursued by the enemy, it's going to be a slight problem. So I'm going to go over here, get spotted, and it's going to come after me, but unfortunately the head doesn't really look like it's trying to look at me, so that's a bit wrong, so we need to fix that. And what I want to do is I want to get the position of the player and have the head look towards it. Now, we want to know its position along the x and the z, the x and the z axes, but we don't really care about where it is along the y because we don't want to tilt the head, down to look at it down here, up to look at it up here. We just want to rotate it around. So I'm going to make a new function, and in this new function, which I'm going to call, it's going to be a void function called look at target, we're going to create a height adjusted variable that's not going to, it's going to be on the same position as our robot head for the player. So I'm going to go ahead and make this variable. It's going to be a vector3, and it's going to be called height adjusted target. And I'm going to make it by creating a new vector3, and it's going to be made up of the target dot transform dot position dot x for the x, but then for the y, because it's the up and down, we're going to take a look at the robot head because we want it to be set to the same height, robot head dot transform dot position dot y, and then we're going to get the target, not transform, the target dot transform dot position dot z for the last one. I'm going to close it off. Now we're going to get the direction from our robot head to our height adjusted target. So it's going to be another vector3, and it's going to be called direction to target. And it's going to be equal to just the height adjusted target minus the position of the robot head. So robot head dot transform dot position, and that'll give us the direction we need. Now what we're going to do next is getting a little bit complicated, but if you hang on there with me, hopefully you'll understand some of this. We're going to be using a function in the vector3 class called dot, and you can see here in the API it has a description for us, and what it says here is basically it returns 1. First off, what it takes is 2 directions. So basically we have a vector going this way and a vector going, say, that way. Then what we're going to do is this function is going to return 1 if they are going the same directions. They're both going like forward or something like that. If they're going in opposite directions, they're going to return -1. And if they are perpendicular, as in they're intersecting at 90-degree angles, then it's going to return 0. So if I go ahead, I'm going to try to visualize this a little bit for you. So here's our circle, and say this vector is going forward. It's going like this. Well, then this is going to be 1. And right behind it is going to be -1. So if our second vector is going this way, then the dot product is going to return -1. If our second vector is going forward, it's going to return 1. And if it returns, if our angles are going either of these ways, it's going to return 0. And these vectors here, if this is our second vector, it's going to return 0.5. But if it's going one of these ways, it's going to return -0.5. So what we're going to utilize is the right vector for this. And so the right vector for our robot head is this red arrow. It's going here off to the side. And since we're being viewed from the front, so we're not being viewed from anywhere back behind, we can say that basically if the number is between 1 and say 0 here, then it's somewhere around here. Or if it's between 0 and -1, then it's somewhere over here. And so what we're going to do is we're going to check to see, we're going to try to get to rotate in order to get the number to be close to 0. Because that 0 is perpendicular, so it would be facing this way. So if I go back over here, we're going to create some if statements. So our first one is going to be just checking if vector 3 using the dot function, and supplying to it, we're going to pass in the direction to target and the robot head dot transform dot right. And we're going to see if this is greater than 0.1. So we're going to give it a little bit of margin, so it doesn't have to be right at 0. And what we're going to do is close that off. And in here, we're going to rotate it in the direction sort of towards getting close to being at 0. And I've done this before, and what I found was that using the -1, so this one here, rotated in the right direction. So you might just have to try and error figure out which one of these two you'd use, but I figured out it was this one. And so we got that. Else, and then we just can copy this part here and just change a couple things. Else, what's going to happen is we're going to check to see if it is greater than -0.01. So if I go back over to Photoshop, you can see here. So basically, if it's down here somewhere, or sorry, yeah, it's over here somewhere, then what we're going to do is we're going to do the other direction. So just like that. So I'm going to go ahead and save this, and we're going to go back into Unity. Well, first, actually, we need to call this function somewhere. Let's go ahead and do that very quickly. So copy that, and we're going to put it in our pursue, just right here, the very top. We can put it there. And now we can go test it out. Hopefully there won't be any errors. Not really too complicated code, it's just the dot product's kind of hard to understand right away. So let's go ahead and test this out. I'm going to go ahead and play it and make sure that it will track us pretty well. I'm going to go over to it. And hey, look at me, look at me. Okay, cool. So we're looking at me, going this way. And it looks like it's getting stuck. So something is obviously wrong with our tracking. Let's go check that out. And it looks like this is going the wrong direction. We want to be checking to see if what we're getting out of our dot product is less than -0.1, because we want to see if it's going into this area here, so we can adjust and move it back towards this. So we've fixed that now. Let's go ahead and save it and go run it. And the problem we were just having was a logic error, because there was something wrong with our logic. If you have an error that comes up down here, and you can't run the game, that would be a syntax error. And there's also runtime errors that pop up while you are running the game. So just some fun facts there. And let's see if this is working. So go this way. Looks like it's tracking me going this way. And I think we got it now. I think we are good. So thanks for watching, and I'll see you in the next one.